आज का हमारा टॉपिक है 2,4 and 3,5 directing groups. 2,4 and 3,5 directing groups. Two, 4 and 3, 5 directing groups. Now listen to this. When we have a benzene ring, for example here, this is a benzene ring, and we have to do its nitration. Substitute one of the hydrogen with NO2. That is called nitration. As far as the benzene ring nitration is concerned, how many hydrogen atoms with the benzene? 6. Out of 6, any one can be replaced. For example, let's say this one is replaced, and it becomes nitrobenzene. So what it becomes? Nitrobenzene. Even if this hydrogen is replaced, you say it's the same thing. This is also nitrobenzene. There is no difference. Because when in ring, wherever the substituent group attached, that becomes number 1. In this case, this was number 1, number 2, number 3, number 4, number 5, number 6. So 1 nitrobenzene, this is also number 1 now here, down. 1, 2, 3, 4, 5, 6. So that's why we don't distinguish between them. We say it's a nitrobenzene, not 1. So when first hydrogen is replaced, NO2 can go anywhere. But on the other hand, when you got one replacement, for example, on the benzene ring, we have got CH3 replaced with the hydrogen. Okay. Now there are how many hydrogens left? 1, 2, 3, 4, 5. Now if we replace the nitro, for example, NO2, now it's not the benzene ring choice. It is the choice of this CH3, where to direct the incoming NO2. The one is just like a house. One tenant has occupied. Now that tenant has to decide the further incoming tenants where they have to go. On the second floor, third floor, fifth floor, sixth floor. Are you getting my point? So whenever on a benzene ring a group attaches, that group decides where they will go the next incoming group. And as far as this direction is concerned, this group direction, there are actually 2 types of groups. Number 1, just like my methyl is 2,4 directing group. What is the meaning of 2,4 directing group? That methyl will direct the further substitution either at carbon number 2 or 4 altogether. For example, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So it means the further substitution will be directed at 2 or 4. So now NO2 will have to go and necessarily substitute at either carbon number 2 or carbon number 4. It cannot be substituted at what? 3 and 5. 6 is even 2 now, because why I'm just saying these 2 positions are exactly the same. Because if I go and go the numbering this side, so 2 is here. If we start and go numbering on this side, then 2, 3, 4, 5, 6, then this becomes 2. So I hope you understand what I'm trying to say. So though both sides you consider it as 2. So methyl is one of the group. Why? I'll tell you later. But at this moment, what I'm trying to tell you, okay, when a benzene ring is substituted, the first group that comes in, it has to direct the further substitution. And there are 2 types of the groups on this basis. For example, methyl is one of those groups which direct the further substitution either at carbon number 2 or at carbon number 4. So therefore, they are known as 2,4 directing group. There is another group. For example, look at this. If I have COOH and you have to substitute nitro on this, It is not going to direct at carbon number 2, 4, and 6. What is left behind if it's not directing at 2 and 4? What is the other two positions? 6. 2, 4, 6 is the same, na? So what is the other position? 3 and 5. 3 and 5. So COOH is one of the groups which directs the further substitution at carbon number 3 and carbon number 5. This is known as 3, 5 directing group. Obviously, it is based on something, right? And that thing is the electrons pushing and electron withdrawing effect, but we'll discuss in the later part. At this moment, I just wanted to make you clear that as when first group comes and substitutes on benzene ring, it has to direct the further substitution for the further incoming groups. And as far as this is concerned, there are two types of groups. One, those who direct at the further substitution carbon number 2 and 4, known as 2,4 directing, and the others which direct for the substitution at 3 and 5 are known as 3,5 directing groups, right? So now I'm going to dictate and make you write for this. Okay, write down, please. When benzene undergoes substitution, the first group that is substituted directs the further substitution. There are two types of groups. There are two types of groups. Number 1, 2, 4 directing groups. Like there are two types of groups. Number 1, 2, 4 directing groups, which direct further substitution on carbon number 2, 4. I'm just writing in bracket 6, so that means for example, OH, OR, NH2, NHR, NR2, all the amines actually. This is kind of alcohol or something. NHCOR, alkyl, Any alkyl or CH2, all the amines, and Cl. When they come on the first place, they direct the further substitution at carbon number 2 and 4 of the benzene ring. Okay, here are they. As I told you, for example, if this is CH3 and we do react it with the concentrated nitric acid, concentrated sulfuric acid at a temperature of 50 to 60, you see what happens? It's going to direct the further substitution at this or this or this point, okay, which is 2, 4, and 6, okay? So this is, here it is, either this or this. All right. And then this case, if even is on this side, you know, the numbering starts from this side. So these two are the same. Both of them are 2 nitro. On the other hand, number 2, 3, 5 directing groups. Which direct the further substitution at carbon number which direct the further substitution at carbon number 3 or 5. For example, NO2 is a 3,5 directing group. NH3 is a 3,5 directing group. CN is a 3,5 directing group. CHO is a 3,5 directing group. COR is 3,5 directing group. COOH carboxylic acid, ester COOR, they are 3,5 directing groups. For example, in this case, here is the COOH. And if I do the nitration for this nitric acid, sulfuric acid, 50 to 60. And then what happens? Look, if this is COOH, so it goes at carbon number 3 here. NO2, okay? Plus H2O. Now this is 3 nitro benzoic acid. Okay, so this is the difference between 3,5 and 2,4 direct. So you remember the same thing. When methyl was there, the nitro went on which substituted at which carbon, number 2 or number 4. But when already COOH was there, the same nitro is now substituted at carbon number 3. Right? So now how the examiner asks you the questions, right? For example, look, here is the question. You have to draw this with me. They say this is a benzene ring having methyl group attached on the top. They say you have to react with the reagent and form a product. And this product reacts again with another reagent and forms another product here. And the last product which is formed is what? This one. And they ask you, what is this intermediate? I'm giving you 2 minutes. Two minutes.
Intermediate to CL. So if we if we do for benzoic acid, then KMNO, then KMNO4. Benzoic acid
What do you mean? Now, if I take, for example, let me give you the two ways. Then you have to tell me which one is. Now, one thing which is clear that methylbenzene is to be converted into benzoic acid and 3-chloro. So it means I have to oxidize this methylbenzene to become benzoic acid. And I have also electrophilic substitution of the chlorine. Now, the point is which one I have to do the first? Chlorination or oxidation? If I look at the product, I clearly can see that the product is installed at carbon number what? 3. So I got to know that the first group that should come in should be a 3,5 directed group, because my end product containing the substituent group at carbon number 3. So it means, yeah, it means for the first, I have to take the methylbenzene and oxidize it. If I oxidize it, the reagent will be MnO4 negative / OH negative followed by H positive. So it is oxidized to give what?
So can we put KMNO4 on the reagent?
KMnO4 is the reagent. MnO4 negative is the KMnO4 short form. Now it has become benzoic acid. Now if I react it with Cl2, darkness, anhydrous, AlCl, catalyst. Then what happens? COH has further substitution at 3-chloro, right? Let's say, for the sake of argument, if I would have done other way around, then what happens? Let's say if I chlorinated it first. If I reacted it with Cl2 gas, anhydrous AlCl3, and darkness in the first step, what happens? Yes, now in this case, the chlorine that will be substituted, because CH3 is a 2 or 4 directing group, is going to go at, let's say, carbon number 2. Okay, so this is what? 2-chloromethylbenzene. And then if I oxidize it with MnO4 negative / OH negative and H positive, it's going to be this one. Here. So final product would have been 2-chloro, right? So this is how they ask you the questions related to this 2, 4, and 3, 5 directing groups, right? So once the group is attached, it directs a further substitution either at carbon number 2 or at carbon number 4, depending upon the situation. For example, look at this question here. This question which you mentioned, Aris, I'm going to display it here. Pay attention. Here. Can you see the two diagrams? The methylbenzene turning into what? 2-chlorobenzoic acid and 3-chlorobenzoic acid. That clearly tells you in one product.
First, chlorination has been done. Chlorination has been done, and then turn into.
Yes. In the first case, in order to put chlorine at carbon number 2, the first substituent group must be 2 directing, 2,4-directing. So that's why we know that the methyl is 2,4-directing group. So let's do the chlorination first. So it will become 2-chloromethylbenzene, and then you add. Similarly, on the other hand,
Coming into benzoic acid.
yes, then do the oxidation first and turn into benzoic acid. And then you can do the chlorination. Then it's going to go at carbon number 3. Clear? Here again, look. What is the difference? This is Y, this is X. At which position X is? This is Y, this is X. At which position X is? So it means Y should be what? 2,4-directing group? This should be what? 3,5-directing group. Right? Here are the list. The electron withdrawing groups are actually 3,5-directing groups, and electron donating groups are 2,4. Can you just add into your notes as well, please? That 2,4-directing groups are actually the ones which are electron donating groups, and 3,5-directing groups are the ones which are electron withdrawing groups. Now look at this. If you reacted with Br2 plus AlCl3, sorry? Okay.
सर
Yes.
सर पहला वाला था डायरेक्टिंग ग्रुप डोनेटिंग ग्रुप था इलेक्ट्रॉन और सेकंड वाला क्या था
विथड्रॉइंग एक इलेक्ट्रॉन विथड्रॉइंग है और एक इलेक्ट्रॉन डोनेटिंग है ओके गॉट इट नेक्स्ट Look at this. Yeah, all right. Now here. We have to identify these D and E, bacho. Can you identify D and E?
D is penetration volume. NO2 will attach.
D is what? D is nitration. At which carbon should I attach? On the top. I can see at the product, okay? And then what is step 2? What is this? How I have to turn it?
From The excess of H.
No, tin with concentrated HCl. Reduction. Heat. Then what about E? Can you identify E? What do you think? You can look at the phenol.
Instead, before its preparation of phenol.
Aries, you can't figure out? Ayla, are you there? Not maybe, surely. Because phenol has only one preparation method. It is prepared from BDC when added with warm water.
But where will it got and second nitrogen?
That's balancing thing. No? Okay. So BDC is converted into phenol by adding warm water. And still you can also guess from here, NaNO2 and HCl, they are the reagents. The second N comes from here. Okay. Next. Okay, before we move on to the next chapter, I just wanted to make sure that you know all the relevant information related to phenol, phenylamine, and benzene and methyl benzene. So 4 functional groups we have discussed up till now, right? And I think we have all the information which is needed to make this, okay? Okay, right. So, okay, next chapter we're going to start, that is the derivatives of carboxylic acids, right? Carboxylic acids and the derivatives of carboxylic acid. That's the next chapter for this, okay? Derivatives of carboxylic acids. This is the name of the chapter, carboxylic acid and its derivative. Okay, now if I tell you one thing, that, for example, look, look at this. This is RCOOH. These are the carboxylic acids. Now, if I remove this OH, let's say for the sake of argument, and replace with any other atom other than carbon, for example, it is RCO and I put Cl here, then it becomes obviously another functional group, RCOCl, which is named as acyl chloride, but we categorize it as a derivative of carboxylic acid. Okay, we just categorize it as derivative. Are you getting this? Is another new functional group, but we can categorize this is one of the compound derived from carboxylic acid. Similarly, number 2, if I have RCO and replace the OH with another OR, I mean carbon chain with oxygen. I hope you identify this group of compounds known as what? Esters. We already know this. right? So this is another functional group, but we can categorize it as a derivative of carboxylic acids. Next, RCO. And if we replace NH2 here, ammonia is NH3, na? So let's say I took one hydrogen off from ammonia, look, this one, and rest of NH2 is here. Okay, so it becomes RCONH2. This is another functional group known as amide. This is also derived. And in number 4, I'm going to take this hydrogen off, this one. It's a amide, but I'm going to replace one of the hydrogen of amide on the nitrogen to make it RCONH and then R. So this is RCONHR. This is known as N substituted amide. And substituted mean nitrogen substituted amide, right? So this is how right? So these are the 4 derivatives of carboxylic acid. Okay, now in the next class, we'll discuss them one by one. I'm going to stop here for today and we'll discuss this, the first, sorry, acyl chloride and the reactions and everything, right? Thank you very much. That's all for the day.